what's the domain of this function, right, in terms of x. But so different value of x will decide the convergence or divergence of the sequence, right? For some value of x, maybe the sequence is convergent. For some other value of x, maybe it's divergent. So the domain and range of this function, meaning when is this sequence convergent? In other words, what value, what kind of x makes this sequence convergent? Right, that's the meaning of the domain. So 1 over 1 plus n to the power of n is equal to e to n times log 1 plus 1 over n. Right, I can use Taylor expansion. Right, n approaches 0, n approaches infinity. Right, this term approaches 0. Because the reason we want to use Taylor expansion is that we want to determine the speed at which this term approaches 0. Because this term approaches e, so will this term. Right, the speed. Taylor expansion with piano remainder. E n times. I probably need 3 terms. First term 1 over n. Second term minus 1 over 2 times n squared. Next term plus 1 over 3 times n cubed plus little o of 1 over n cubed. Right. So little o of 1 over n cubed is that this term approaches 0 faster than 1 over n cubed. Right. So little o can be viewed as some sequence that's approaching 0. So the whole thing becomes e to the 1 minus 1 over 2n plus 1 over 3n squared plus little o of 1 over n squared. Right. N can multiply inside little o. Right. This is easily verifiable. So e to the power of 1 becomes e times e to the remaining. Right. So e taken out times e to the minus 1 over 2 plus 1 plus 3 n cubed plus little o of 1 over n squared. Again, so this term approaches 0. Again, Taylor expansion. E times, right? So previously I expanded 3 terms. Now this time maybe I expand 2 terms. I think that will be enough. Right, so this whole term can be treated as whole term, right? So first is 1. 1 plus x. X is this, minus 1 over plus 1 over 3 n cubed square. 3n square. 3n square. Little o of, right, plus half of x. Half of x. Negative plus right, half x plus little o of half x squared. Little o of x squared minus plus square. Again, keep in mind, little o means some sequence that's approaching 0 times this thing, right? That's approaching 0 faster than this. So now all I need is that is equal to e times, I'm going to multiply this term out, right? Multiply this term out times half combined with that term. Still have 1 minus 1 over 2n plus 1 over 3n squared plus little o of 1 over n squared. And so this term, this whole thing square. First term is 1 over 4n squared, right, times half plus 1 over 8n squared. Okay. The other terms, it's either some constant over some constant n cube, or n to the power of 4. But all of the terms approach 0 faster than 1 over n squared, obviously, right? I can put them all into this little o of 1 over n squared. Right? So the same goes for this term. Right? So this term. The first term is 1 over 4n squared. Now the other terms all approach 0 faster than that. So I don't worry about them. I can just treat it as little o of 1 over n squared anyway, right? Put it in here. Right, so this is all I have. Okay. So this time I can maybe combine those two terms, right? 24 times, so 8 plus 3, 11. 11 over 24 times, right, n squared, right, it's gone. So that is, yes, that is this. So again, I have this. So this becomes that. So likewise, 1 plus 1 over n plus 1 to the power of n plus 1 can easily become e times, the only difference is that minus 1 over 2 times n plus 1 plus 11 over 24 n plus 1 squared plus little o of 1 over n plus 1 squared. But it's the same as 1 over n squared, right? Little o of, because they approach 0 at the same speed. Right? So eventually I'll take their difference, right? This minus that. So 1 plus 1 over, right, n plus 1 minus 1 plus 1 over n to the power of n now becomes e, right? Extract it out. 1 minus 1 gone. So this minus that becomes this. This becomes positive, right? Minus this term. So 2n n plus 1. I have this term multiplied by n plus 1 minus n. I have 1, exactly 1 on top. And again, this and that common denominator is, again, this term will minus this term, right? 24 n squared times n plus 1 squared. I believe that's the common denominator. So I have 11 this times n squared minus 11 times n plus 1 squared. All right, I'm going to deal with this. So little o come together, right? Just becomes little o. All right, so good. Right, you have two terms that's both approaching 0 faster than this. So altogether, of course, their sum also approach 0 faster than this, right? So eventually, like I said, what happens to the top, right? So 11 n squared term is gone, right? All I have is n term, right? So I have minus 22 for n term. I have that. Minus 11, a constant term. But that doesn't matter because the bottom I have leading term of 24 n to the power of 4. Right, that's the leading term. A leading term here on the top is only this term, right? So n canceled out. Right, so effectively speaking, I have just this term will approach 0 at what speed? At the speed of some constant over constant times n cube. Right? That's approaching 0 faster than 1 over n squared, obviously, right? So I can put this into that, right? Altogether, they become little o of 1 over n squared. Now it's easy. Now I have n times to the x times their difference times this, right? Times so e, let me put it in front of here. Right, so eventually I have 1 over 2n plus 1, right? Plus little o, 1 over n squared. Right, so remember, so again, this leading term at the bottom, right, 2n squared. Right, that tells me maybe x cannot be larger than 2, right? If x was larger than 2, then what happens is that we have leading term here, power is greater than 2, but down here the power is only 2, right? So eventually we'll tend to infinity. All right. So this term, right? We don't even have to worry about this term, right? So this term already approaches infinity. Right? Maybe that's not what we want. Right? Maybe we just want x to be when x is equal to 2. Right? Maybe that'll approach leading term constant, right? 2n squared, 2, right? 2. I think it'll approach half e. Right? Half e constant at the bottom. And when x is less than 2, what happens? Like I said, leading term is 2n squared, right? We have some n to the power of less than 2, right? Eventually we can still have some n to the positive power down the bottom, so eventually still approaching 0, right? So how about this, right? Little o of 1 over n squared. Like I said, we can multiply this inside little o. I can still have 1 over n to the positive power. Still approaching 0, right? Little o, right? Still approaching 0, right? Eventually. Still approaching 0, right? So that's in fact the so-called domain and range, right? If we say this is a function in terms of x, that's the, we can say, so that will be equal to half e if x is equal to 2. That will be equal to 0, right? When x is less than 2, right? Piecewise function, right? That's the so-called domain and range.